All right, students hitting the math connections here out of 3.3. So the MCs, if you will. Let's see here. Do elementary students still have to learn their basic facts when the calculator is part of the curriculum? Well, you can take a look at that. Let's see here. 3.3. Oh, question 2. I was jumping to question 3. Let's see here. Explain whether it's important for elementary students to learn more than one model for the operation of subtraction. So give me your explanation for that. If you were approaching a student, what would you say to them? Do they need more than one or not? All right, let's see here. What else do we have? 8 through 15. Okay, so 8 through 15. Okay, so there's a couple down here, 8 and 9 and 10. And then I'm taking a chunk out of the connecting math to the classroom. Remember, CMCs, they used to be called questions from the classroom. Now they're connecting math to the classroom. So those are identical to what you might see actual students asking. Those are also the ones I emphasize. Those are kind of a big one. Let's see here. Consider the following subtraction algorithm. So someone is giving you an algorithm, and it looks like they're doing some pieces together, and you have to say why it works, and then have to use it to figure out another problem. I like that. I like that. Okay. Let's see here. Explain why paper and pencil addition and subtraction, the terms trading and regrouping, so fair trading or regrouping, are used instead of the terms carrying and borrowing. We've mentioned this a couple times even in class, so I want to hear your explanation on this. If you are still in the mindset of thinking, oh, I carry this number, or I borrow this, remember, you'd have to, at least to me, if you were going to do borrowing, and let's look at where that comes up traditionally, right? So if I was going to do borrowing, oops, I don't want pink, I'll take red. So if I was doing borrowing and I had 33 and I was taking away 17 and somebody said, I want to borrow, I'm going to borrow some of this. Okay. Then at the end of the day, right? 2 minus 1 is 1. Yeah, I think you said I borrowed from it. I have to give it back at the end. So at least it makes sense why someone might write down an answer like 26. I borrowed, then I gave it back. And truthfully, you could do this. You could absolutely do borrowing, like I borrow from you to make this work out. Here's how, though. It's not the same as what you grew up with. What you grew up with was not borrowing. Even though the word was borrowing, that doesn't mean it was accurate. If you want to borrow, come borrow 10 $1 bills from somebody. So now you have three $10 bills and you have 13 $1 bills. You actually just borrowed, right? If you're going to do that, borrow 10 ones. Okay, so now we come to the end of the day. 13 ones now minus 7 gives me 6. 3 tens minus 1, 10 gives me 26. But what did I do? I borrowed 10 ones from you. I need to give you back $10. I don't have enough ones. How about I just give you a 10? So my final answer is 16 because I'm going to trade back to you one $10 bill. See how I borrowed and then I gave it back. That's fair. We get the same answer and we don't have to worry about the confusing wording because you didn't borrow here. You took three $10 bills, you kept 2 of them, and you gave somebody a $10 bill and you got 10 ones. That's not borrowing, right? So again, we want the language of mathematics to match what students already understand. Okay, let's see here. The student says 0 is the identity for subtraction because a minus 0 equals a. Great question, student, right? How would you respond? You might say, I need to remember what identity is for addition because we do have an identity for addition. Jump back a few pages in the book to section 3.2, find the identity for addition, and see if this meets that definition for subtraction. Student asks why we're using subtracting to determine how many more pencils they have if nothing is being taken away. So this is linked to possibly one of the techniques or models that we saw in section 3.3. So again, how many more pencils do you have? You're not taking away. So again, this comes back to the student's understanding of subtraction and maybe your own. You think of subtraction as being something being taken away. It does not have to be taken away. Okay. Technically, it's the difference between two quantities. And so this actually seems to tie in with that. Student claims set a whole number is closed, and they're going to show you They found 1, 2, 3, 4, 5. They found like 5 examples, it looks like, and they say they can keep going all day. And they always give you a whole number when the subtraction is performed. How do you respond? And yeah, this ties into what we did in chapter 1, right? How many examples do I need to show you before you conclude it's always true? And hopefully from that chapter and even from the exam that we took, you would be able to say, it doesn't matter how many examples you show me. All it takes is one counterexample. So we got to be really careful with that as we go forward. First grader claims 2 minus 4 is 0 because you can't have less than nothing. Okay, I'm going to let you respond to this, student. And notice here's another first grader claiming that 2 minus 4 is equal to 2 because all you got to do is turn the numbers around. All right, how do you respond? These are both fairly common as students are learning the ideas of mathematics. Okay, let's see here. What do we have? 2, 8 to 15, 18 to 20, and then 22. Okay, so let's see here. I guess you can skip Ashton. I'm telling you, these have got to be celebrities, right? They've got to be. Ashton Kutcher. Where's Demi? Anyway, all right. Oh, not Demi anymore. Who's he with? Anyway, who cares? I'm not up on all the hot gossip anymore. We have 18 through 20. So here is an own algorithm for subtraction. You know what? I think we saw this in our class on that first day. I think Shaney came up with something very similar to this. So take a look at this. How would you respond if you were the teacher and someone did something like this? Is it correct? Will it work? What are they doing? These are the questions you want to answer when a student comes into you. Oh, let's see here. A student did this, began by finding this, then wrote 9 minus 8, wrote 51 as the answer. How do you respond? I mean, you want students to be able to kind of check it. When you as students come to me and say, am I on the right track? I think you'll probably notice I end up saying, hey, well, why don't you check it? See if your answer makes sense. Just remember, subtraction is rewriting addition. So that's something to kind of think about. All right, let's see here. Myriad subtracted this minus this by writing this minus this minus this, and wrote 2, 3 as the answer. Oh, okay, that makes sense. Why does this make sense? How would you help her, right? So the student isn't really doing anything wrong, are they? As a matter of fact, maybe even their answer, the values that they got turn out to be correct. They might just be missing one key component. So keep that in mind as you're answering these student questions, right? What did they do correctly? Where are they off mathematically? Okay, so that was 18 to 20. I also assigned 22, question 22. I love this problem. Polly subtracted 549 from 5004 as follows. How would you respond? So again, crossed off the 500, wrote 499. Is that okay? Should they not be crossing off 500? Should they be writing not 500? They should be writing a 9 here, a 9 here, and a 4 there. 3 separate numbers? Or is it okay to write 499? Was there a mistake that was made? If so, where was the issue? Did the student check their work? Are they on the right track? All of these things are questions I want you to be able to find. Okay, let's see here. Group work 2. Group work number 2, right down here. So again, in algorithms not included is partial differences. Partial differences is a pretty powerful one if you're going, but just realize we don't do partial differences in this section because this section is geared towards whole numbers. So the question to you is, why do you think it's not included? Come up with a response to a student that shows this way of subtraction. Do a different problem. Will this always work? And is it a good idea to do something like this? Okay, so partial differences and really understanding the ideas. All right, that's about it for the MCs. MC, I feel like I grew up with some rap music that everybody's like a YumC, MC Hammer, Young MC, right? Anyway, I'll leave that out for now. I hope you're all doing great. Off you go.